Hello. Hello. Good afternoon, everyone. Hope you can hear me. We'll start in few minutes. Okay. Okay. So let's get started. So this is your tutorial for week 8, mainly questions from Fourier series. All of you must know. I think most rest of the tutorial also will be from Fourier series of function, Fourier series representation of function. Okay, so this is Rahuldev Ghorai from ICT Tiruvananthapuram. So in today's lecture, I will be mainly solving uh, questions from assignment. Okay, and if time permits, I will also try to do for week 9 a solution. I will try to solve the questions from assignment of week 9. Okay, because I think now the week 9 assignment is going on, but due to some health problem, I could not take one class in between. I mean, that class is just replaced by this, I mean, the transform to this class. So that's why I'm little bit lagging behind, but I'll try to do if time permits. Most probably time will be okay. I'll get some time and I will start with few questions and answer from week 9 also. Okay, so stay tuned for the week 9 for the week 9 solution session, but for now we will start with week 8. Okay, so this is your first question. So it says that if a Fourier series function of a function fx is equal to x square plus 1 defined on minus pi to pi is given by this. So mostly you will see the Fourier series of function f, any arbitrary function f is given by this, and you need to mainly find out a n, b, and bn, right? So mainly we try to write the function, write a periodic function in terms of cosine and sine, so that we know the property, because the cosine and sine functions are well known. I mean, it's well studied. The trigonometric functions, sine function and cosine functions, are trigonometric functions which are well studied. So we can handle them, and if we can handle them, then the linear combination or the infinite sum, combined sum of sine and cosine, that also we can handle. So that's why we mainly write the function, the periodic function in terms of sine and cosine trigonometric functions. Okay. So here also, so there is a motive behind. Also, I should not say that is the motive. I mean, that is one of the advantage of expansion of Fourier series expansion of a function. But the motivation maybe was to solve PD and all those things. So I am not going into that. So what I am saying here is fx is x square plus 1, which is the Fourier series expansion is given this. You need to find out a naught, an, and bn. Here in this question, you need to find a naught and an, right? So how do you do that? So this how to solve this? So mainly I showed in the last class also, right? This integration. So what we have to use mainly integration of cos nx cos mx, right? Integration over the minus pi to pi, right? Integration over sin nx sin mx and integration over sin nx cos mx. So mainly you need to know what are the values of this. So one trick is you should remember cos and sine, they are orthogonal. What's the meaning of orthogonality? For a vector, you know what is the meaning of orthogonality, right? So two vectors are orthogonal means they are perpendicular to each other, right? But when you say two functions are orthogonal, means their, I mean, when vector is orthogonal, their the angle between them is 90 degrees. So the dot product of two vector or the inner product, whatever you want to say, is 0. And here in this case, cosine and sine functions, their inner product we can define like integration of their product, right? So when you define like that, this product should be 0. I mean, this is 0. This will be 0. Sin nx, so that implies sin nx and cos mx. So one can show that this is 0, and that implies they are orthogonal, right? And if you use this, then you can show that as mainly you can put it 0 to 2 pi for 0 to 2 pi and 0 to 2 pi, right? So they're orthogonal. And what is this value? This value will be 0 if m not equal to n, and pi if m equal to n. Same 0 and pi, m not equal to n, m equal to n, right? So mainly if you know these three, you can evaluate what are an, am. So even so, if you know this, then you can evaluate. You don't need to remember the formula for an and bn. You just multiply the function. So let's say I'll show for one maybe. Let me use the black color. So You have fx is equal to a naught over 2 plus sum over n equal to 1 to infinity a n cos nx plus bn sin nx, right? You have this. So how to evaluate? So if you multiply fx, the both side of this equation by cos mx, let's say cos mx, I multiply by cos mx and I take from 0 to 2 pi, right? That will be, and we don't forget to write dx also, so that you are writing derivative. So 1 by 2, so a naught is also constant, it will be out taken out, so 2 pi cos mx. So I multiplied and I multiplied in and taking derivative both as taking integration. So plus summation n equal to 1 to infinity a n integration over cos nx cos mx 0 to 2 pi plus summation n equal to 1 to infinity bn 0 to 2 pi sin nx cos mx. So you know this last term, that is 0 always, right? Because they are orthogonal, right? So that's why they are 0. That term is 0 always, right? So but what else will have? Cos, this is cos mx, it will look as it is equal to, see this a naught over 2 times, or 0 to 2 pi cos mx, this one is also 0. Why? The integration will be sine negative of sine nx, right? Sorry, just sine nx mx over m. The constant I'm not telling, but the what will be constant will be there. Then you take integration from 0 to 2 pi, and that integration, if you evaluate the integration limit, lower limit and upper limit, they are same and they are 0, so it will be 0. Plus, in this second series, you will have the last series also. I am writing 0. I'm writing it will be 0 because they are orthogonal. And the in the middle series, I mean the second term or second series, you will have only mth term. So when n equal to m, you will have the value, otherwise. So cos mx cos square mx dx, right? Why? Because cos nx and cos mx, if m and n are not equal, then uh, the value will be 0 from 0 to 2 pi. So by this, what you can show that am and this integration value, now it will be easy to evaluate, and it will be am times pi equal to 0 to 2 pi fx cos mx, and then m will be 1 over pi 0 to 2 pi fx cos mx. See, you can easily derive. So no need to remember am is to be like this. If you remember the orthogonality of cos and sine, you will just easily derive. Similarly, bm and a naught, you can derive it easily. So a naught will be mainly 0 to 2 pi fx, just fx. So that is the average of the function. Okay. Okay. So once you know this, in this question, one can find out. Let's try to find out a naught. You can easily find out, right? So what will be a naught? Let me write in a different color so that you can. So a naught is nothing but 1 over pi, as I said. So in this case, it is the interval length of the length of interval is to pi, but the interval is minus pi to pi. So what we will take, it will be from minus pi to pi. It's very easy, just a different interval. So fx dx, right? A naught is fx dx, as I said. So then 1 over pi minus pi to pi x square plus 1 dx, right? That will be 1 over pi x cube by 3 plus 1 times, sorry, the limit will be minus pi to pi. So what do we get? Will be 2 times pi square over 3 plus 1. Pi square over 3 plus 1. B is correct. Similarly, you find out an. What will be an? An, just put the value fx here. An will be x square plus 1, 0 to minus pi to pi in this case, of course. In this question, it will be am will be 1 by pi minus pi to pi. Fx will be x square plus 1. I am writing also, just you evaluate it. X square plus 1 cos mx dx. That will be this. Okay. So you evaluate it easily. You can find out am values. So for each m, what are the values for am? Okay. See, solution is also provided this answer also, solution also. So solution came out to be 4 cos n pi over n square. Okay. You can check it also. Now we'll move to the next question, which is fx is given x square plus x, gx is given x square plus 1. So which of the following options are correct? Fx is an odd function, gx is an even function, fx gx is odd function, fx g is neither odd even. So this is nothing to do with Fourier series, I think. Okay, but yeah, I just try it. It's easy. I should not do also maybe. I mean, know the properties of like what are the property of fx? F is even. Okay, what will be f of minus x? F of minus x will be x square minus x. You cannot say anything about fx, right? Whether it is odd or it is even, right? Because if it is odd, it would have come fx, sorry, minus of fx, which is not, it is not minus of fx. It is neither equal to f of minus x nor equal to minus of fx. So odd or even, you cannot say anything. So gx, for gx, just put instead of x minus x, it will be same, x square plus 1 is equal to gx. So g is even function. So this one is correct. So this is how you try for fx times gx, fx times gx, right? So I write directly. I will try f of minus x, g of minus x, right? That will be x square minus x, right, times x square plus 1. So if you it will be easy to see, because fx times gx will be fx times gx, that will be x square plus x times x square plus 1. Can they be equal for all x? Because the functions are defined over full real number, right? So they cannot be equal, because you see this has a root like x times, I mean, if they are equal, right? If they are equal, and they are equal for x equal to 0, that is true. But if you take some other number, it won't be 0. So what I'm saying, for x not equal to 0, if they are equal, then it has to happen that x plus 1 should be equal to x minus 1, which is absurd, right? So this cannot happen, and that's why this f of minus x of a g, fx gx, they are not equal. Neither they are equal nor they are like equal to minus of one is negative of another. Neither they are equal nor they are just one of them is negative of another. So that's what I wanted to say, and that implies they are neither odd nor even. Okay, so yeah, it was very easy. I won't go much in this. So what we were mainly talking about this Fourier series, and we are trying to so a function, like given a function, try to provide a Fourier series of the function, and I mean, yeah, try to find out the Fourier series expansion of the function, and then it is, it becomes very easy to quantify the, like, if it is very easy to analyze the function's behavior using the trigonometric function, because they are kind of you are expressing them as a trigonometric function, and their will be like their behaviors are well known, well studied. Okay, so now it comes to the function f of x equal to x over 2 plus 1 in the half range cosine. You have to, what we have to find, what is the half range cosine series of the function f x equal to x over 2 plus 1. So what's the meaning of half range cosine series? What was our usual formula for the usual formula for the Fourier series? So it was a naught over 2 plus summation over n equal to 1 to infinity, like I showed already. This is usual formula, this type of formula. With this is the, for any function, you can think it as for any function, a naught by 2 plus an cos nx plus bn sin nx. But what will be the formula for the half cosine series, right? So you will, if you see it here, the interval is also from 0 to 1, right? So in the interval is from 0 to 1, so x is from 0 to 1, 0 to 1. So to make it at least from 0 to pi, so we usually know from 0 to pi or 0 to 2 pi or minus pi to pi, that's what we do. So that's why here it is, but it is from 0 to 1. So what you can change it, instead of x, if you put pi x, that will be from 0 to pi. So then how you remember this? This will be a naught over 2 plus summation over n equal to 1 to infinity an cos, instead of nx, it will be n pi x, right? Plus bn sin n pi x. But in this case, it's a half range cosine series, so we'll take only this member. So fx should be like approximated by this series. It will be equal to, or it will be approximated by a naught over 2 plus n equal to 1 to infinity an cos n pi x. Why it is n pi x, that you understand, and why it will be like this, because half range cosine series, this will be like this, and then it will be easy for you to evaluate the value for a naught. Mainly you have to find out a naught and an, then you are done, right? And I have shown already how to find out a naught and an. If you don't remember also, you can do it easily. Anyone here, you can try. If are do you want to try, then I
Yes,
can.
sir. Yes, sir. I am trying, sir.
Sure. No problem. I'll wait then for 2 minutes or 3 minutes. No problem. You tell me, okay, whenever you are done.
Yes, sir. Yes, sir. I'll do
Sure.
trying, sir.
Sure. No problem.
Sir, B option, sir.
A option,
B.
B option.
Yes, sir.
Okay. How you got that? What is your A naught?
Sir, A not 5 by 4, sir.
No, A naught. If 5 by 4, then total answer will be 5 by 8, right? A naught should be 5 by 2. Okay. In your calculation, right?
5 by 4, sir. X square by 4 after integration.
Sorry.
That x by 2 will integrate to 5 by 4.
X by 2 plus 1. You have to integrate x by 2 plus 1, right?
Yes, sir.
From what way? 0 to 1, right?
0 to 1.
Okay. But yes, one more thing. So if you multiply it to cos n pi x, right? You have to multiply both sides by sine n pi x, right? Then this one will get cancelled and you will get a naught over 2 times
That
sine.
A not over 2, sir.
Yeah, so this will be a naught over 2, right?
Okay, then it is A option, sir.
Not then. So mainly you have to, how do you remember? So that is the thing. So how do you mainly remember this, that which one you have to choose? Like, what will be the a naught?
Yes, sir. I applied A not directly without dividing 2.
Yeah, that I understand, but this problem, this mistake, many will do. Maybe I have done in my time, right? So that's why I'm telling how to remember this, right? So don't need to remember. So what you do, you have to evaluate a naught, right? From this expansion, right? So you multiply fx. So you multiply with cos nx, multiply by cos n pi x or sin n pi x, right? That I showed. I think you were not in this class like from beginning, but yeah, you can check later. That using this formula, one can show that this can be by multiplying cos or sine function. You can evaluate this uh, cos n pi x a naught, the
Yes, sir.
coefficients a
A
naught.
option, sir. A option, sir.
Yeah, but so what I'm saying. So, but how do you evaluate this a naught? Why it is two times something? Huh?
Yes, sir.
That's what.
A
That's why
not
I'm.
by 2, sir.
Yeah, a naught by two is there, right? So this two will be okay. So you just multiply by sine n pi x and integrate. That will be a naught by two integration. The integration will be from 0 to 1 in this case, and that will be sine n pi x plus 0, right? Because this term, when you multiply and take integration, because of cos is there, cos and sine, that they are orthogonal, so they will be 0. And this integration, what you get in this integration? A naught over 2. So this, in this integration, what you will get is sine n pi x. The integration of this will be minus cos n pi x, right, over n pi, right, 0 to 1. Are we missing something? 0 to 1 fx.
Sir, I saw my that where I have done it. You want to see that paper?
No need to see the paper. But what is the mistake here? It is we are doing that. We also need to know, right? Why it is not coming here? Some doing something stupid. That's why it is not coming. I understand. Okay. So this when you multiply by sine one of the n, let's say, so we in this case even n equal to sorry not n equal to no, how do you obtain this formula? That's what this is easy to obtain, but I cannot obtain here. So okay. Okay, so this way it will be little weird. So what? So you can multiply by cos m by x mainly cos uh, m by x. But this should everything should be similar. Yeah. Okay. No problem. No problem. So this is true for any n, right? I need to find out the value. So if we put n equal to uh, why it's not coming? One minute, let me do it in this way. I'll just check it for like give me some minutes. I will
Okay, sir.
check
Okay, sir.
what is
Okay,
the
sir.
yeah, what is the not mainly. Okay, so this so it seems it is difficult to evaluate this integration. Mainly we have to find out the integration. So yeah, so we have to mainly multiply by cos n pi x. That is true. Okay, cos n pi x that equal to a naught over 2, then the integration value will be sin n pi x over uh, n phi, right? Yes, but instead of doing before doing the integration value, I'll write it as 0 to pi, sorry, 0 to 1 cos n pi x dx, right? And now as it is true for any n, I put n equal to 0. That is also true. So 0 to 1 fx is equal to a naught over 2 0 to 1 cos n pi 0 will be 1 dx, that will be a naught over 2. So a naught over 2, a naught over 2 will be integration of 0 to 1 fx dx. Yeah, so and fx here is x by 2 plus 1, right? So 0 to 1 x by 2 plus 1 dx. So x square over 4 means 1 over 4 plus 1 is equal to 5 over 4. So a naught over 2, that coefficient you obtain, that will be 5 over 2. So this option and these options are not correct. That can be B and D. They might be uh,
Yes, sir. B, sir.
option.
B.
So
B.
why
The
B? What
second part is of B.
AN will be what? What you have got? What is AN?
N minus 1 to the power n minus 1 over
No,
n
first
square
first
pi.
the formula. Formula. What is the formula?
Sir, 2 by 2 by lambda 0 to lambda bound fx cos n pi x by lambda dx.
No, I don't understand. Two
सर
by
वो 2 by the upper bound limit.
upper bound limit.
Upper
What is the
bound 0 to 1.
so one?
Yes, sir. 1.
2 by 1. Yeah. Then
then fx x by 2 uh, cos n pi x by 1.
cos n pi x dx, right?
Yes sir.
That's what.
Oh,
Yeah, whatever you will get, that will be from fx. If you multiply by fx by cos n pi x, and then for only one value it will be there. Then if you get this, that will be the thing. So 2 by 2, then 0 to 1, x by 2 plus 1 cos n by x, and then you do the integration by parts, right? So that's the thing. A naught over 2, so a naught over 2 will be 5 over 4 in that case. So, and this is what you got.
yes sir. Yes sir.
So the correct answer then is B, right? It's not A. So here is some, yeah, this is B, right? So similarly, this one is okay, right? One can do for half sine series. This is similarly one
Yes sir.
can
Same
do.
sir. Same sir.
So a naught will be in this case 0, and bn will be n times. So bn will be, you have to find out mainly bn. N is a will be 0, okay, because you can see a naught is not there. So you will first write fx equal to a naught over 2, and it is half sine series, right? Half sine series means plus summation over n equal to 1 to infinity a n sine nx, right? That's all. Then you find out what is the a n or bn, whatever is that. A n cos nx, b n sin nx, whatever is that. Right? So that is easy. So see, so half range cosine series will be given by then. So bn will be some cos 2x times sin n pi x over pi. So yeah, once you know this, so you find out bn, that will be like this. Okay. What will be the Fourier series expansion of f prime x? Fx is given like this. The given function, is it differentiable?
Yes sir. Yes sir.
The given function is differentiable. Try to find out at 0, it won't be differentiable, I guess. This is a good question, right? It's not easy. Do try, otherwise I'll tell. I'll tell.
Sir, not differentiable. Hello?
Yes, yes.
Not
Function
differentiable,
is
sir.
not function is not divisible, but you can write that the Fourier series expansion of the function. Right. That's
Sir,
the thing.
pi is not equal to minus pi. That is coming, sir.
Yeah. So you said right is defensible, but it's not defensible. So f prime x does not exist, but you can write as a Fourier series expansion. That function what is although it's not defensible, the function can be written as the Fourier series expansion. So that is the thing here. That's the important thing. So they try to find out the Fourier series expansion. How to do that? You have any idea?
No, sir. Please write, sir.
Sorry.
No, sir. I checked that RSD, LSD is not coming equal, but Fourier series expansions are never done before, sir.
Fourier series expansion you have never done for.
F prime.
Okay, so you know for f right, fx. You know for fx. Fx for fx what is this? A naught over 2 plus tell n equal to 1 to infinity an cos nx right plus bn sin nx correct.
Yes, sir. Yes, sir.
Right. So then f prime x will be see this is constant to then n equal to 1 to infinity an cos nx sorry not n take you have to take derivative of this negative of n an sin nx plus n bn cos nx. Right? You understand this?
Yes, sir.
So once you now you have to find so Fourier series expansion of f prime x will be this. But for this, what you need to know only an and bn. If you know a and bn, then you know everything of the Fourier series expansion. So now a and bn, how you can get? So you know fx, fx equal to pi x 0 if pi x if x less than equal to 0 and 0 less than equal to x sorry not x less than equal to right x less than equal to pi this will be just less than right. So fx if you write in this series form what will be your an will be 1 over pi cos nx right integration over fx cos nx minus pi to pi correct. So that implies 1 over pi minus pi to pi. What is fx? Fx is 0 if it is from 0 to pi. So I will not take 0 to pi interval. So minus pi to pi I will break into minus pi to 0 plus 0 to pi. So 0 to pi fx value is 0. So we don't have to consider that. And minus pi to 0 the value is pi x. So pi x times cos nx dx right that implies 1 over pi uh, and pi also will again 1 pi is there so pi get cancelled and what will have integration minus pi to 0 x cos nx dx mainly you have to evaluate this
So how do you evaluate? So it will be x sine nx over n minus sine nx over n dx. So integration by parts I am doing. So this will be minus pi to 0. So if you do integration by x will be coming out, then integration of cos nx, that will be sin nx over n, and then take derivative of x, that will be 1, and integration again that same. Okay, this it's correct. So then what will happen? It will be equal to x sin nx over n minus, so but integration of this will be minus of cos x, that will be plus, so cos nx over n square, another n will come, so minus pi to 0. So that will give you, right, minus pi to 0, yes, that will give you. So when you put 0 or minus pi, this quantity will get vanished. So only you will remember with remaining with n cos nx part. Cos nx part at 0 it is 1 always, but when it is pi or minus pi, that is oscillating, so minus of whole divided. So there what you get, this is an. Similarly you can find out what is bn, right, using the Fourier series of fx. So once you know an and bn, you put in this formula f prime x. So the first term will be minus n times an value will be this one. So 1 minus 1 will be n over n. Negative of that will be the one, the first term. So that, and that will be this term, but this term should come with sin nx. I mean, D option should be correct. All other options you can just discard, even with one value of n, right? Do you understand this? I think this will be D. Yeah, answer is also D. Yes. You understand this whole thing?
Yes, sir. Yes, sir.
Okay. So, write down the function for
Yes, sir.
the.
N से n cancel and minus 1 to the minus 1 to the power n.
Yes, yes. And that should be with sin nx, right? Here, that should be with sin nx. So sin
Sin nx, sir.
yeah, so that's why it is. Otherwise, it would have been also correct, but this is not correct because it is with cos nx, right? So that's how you do it. The answer is also given. You can check it once I upload. So now the next question is this, question 6. Okay, this is easy, right? It's given here that A naught, A n, B n are Fourier coefficient of fx. Already given, right? So once you know that, then you know the what are the values for A n, A naught, A n, B n, right? So A naught should be uh, integration over fx dx, right? uh, and then you get it easily. That's the thing. Once you know a naught, a and bn, then you put the value and you get the answer. So a naught will be 1 over pi integration over 0 to pi, because minus pi to pi will be integration, but the minus pi to 0 is 0, so 0 to pi pi x. So that gives you pi square over 2. A naught will be pi square over 2. So the first term should be pi square over 4, pi square over 4 x plus pi. So possibilities are this and this. And then one of the, if you can find out an whether it is 0 or not, then you are done. If you can show that an is not 0, then it should be equal to this, and then you can show that d is correct. If an is 0, then you have to find out bn also. Yeah, you don't need to find out bn, you can say that okay, option a is correct. So that's how we can easily do these options, the multiple choice question. What's the value for n? You are you trying, Binoy? You want to try or
यस
like?
सर, ए नॉट अभी शुरू किया है सर, ए नॉट स्टार्ट किया है सर.
Okay, okay, no problem. Do it.
Sir, hello.
Yes.
Sir, maybe D correct, sir.
Why maybe? What is your A naught?
A not, sir. 2 pi square.
2 pi square.
Yes, sir.
So how you got that? What will be A naught? A naught will be 1 over pi times minus pi to pi fx, right?
Yes, sir. Fx dx.
Then 1 over pi. So minus pi to pi will reduce to 0 to pi, right? Pi x, because otherwise it in the minus pi to 0 it is 0, right? So you should not take that minus pi to pi, you should not do that.
Okay, I
So
taken, sir, 0 to 2 pi, sir.
why 2 pi? 0 to pi it will be, right? Because the interval is here minus pi to pi,
Okay, sir.
right?
Okay, okay.
So we have to consider in that way. Whenever it is minus pi to pi, you have to take minus pi to pi only. So total length is 2 pi, but it will be minus pi to pi. Okay. So if you do that, then it is pi. Sorry, not pi. So x square by 2. So pi square by 2, right?
Okay, pi square by 2, sir. Pi square by 2.
Yes, yes. So pi square by 2 means, so it can be either can be A or it can be C, not D. D and B are not correct, but it can be A or it can be C. But which one is correct? For that you need to know N. What is N? N is you got correctly, or that again you have done mistake. So mistake means you have to take minus pi to pi. What will be N? Cos nx, fx time cos nx, right? So what is fx? Fx will be 0.
C, sir. C.
Then C will be correct, right? Fx will be not be
Yes, sir.
0. So if it is not 0, it will be minus 1 whole to the power n minus 1 over n square. This type of things you will get. So C is correct. So
Sir,
solution is also given.
that
Yes.
bounds minus pi to pi.
Yes.
That I did
Mistake.
0 to 2 pi and
Ah.
divided by 1 by 2 pi.
No, 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 no. You should not do that, right? Why to do like 1 by 2 pi? So because a naught by 2 is already here. A naught over 2. It's not only a naught. So when you have a naught over 2, then that 1 by 2 pi would actually it will be if you the series will be 1 over 2 pi 0 to that interval time fx. But here that a naught by 2, because of a naught by 2, if you even if you have 1 by pi, a naught by 2 will be 1 by 2 pi times sort about that thing, right? That's why whenever a naught by 2 is there, you have to take only 1 over pi a naught value, because by 2 is already taken here in this one. If it's not taken, then you have to take 1 over 2 pi. That's the confusion. So usually what, that's why people write fx, that will be a naught over 2 plus this summation over this, and then a naught is just 1 over pi fx, and n will be also 1 over pi. So then don't worry about this one, fx cos nx, and another will be sin nx. 1 over pi, 1 over pi, that is okay. Only the thing is here it will be a naught over 2. Then you don't get any problem. Again, no problem here. Right? You can remember like this. That's the standard way people write also, and you can remember this way. See, this is the answer. So Fourier series of a function which is a very discontinuous, jump discontinuity it has, right? So the function will look like, maybe I won't draw this. So draw maybe just 0 point, and the function is 1 or 0. If it is 0 to pi, it is 0. It is, if it is from minus pi to 0, it is 1. So the this function, how it approximate, you will see it will be like maybe because they are combination of sine function, it has to be something like this, and then maybe this, and I mean, okay, not like this. uh, like this, and maximum you will see it will be, sorry, some mistake, it is not this, right? It is like this, and you will see at the latter case it will be oscillating and it will be like this. I mean, what I'm saying, the function when you approximate by Fourier series, when you approximate it by Fourier series, it will look like this. So you take, so it, the Fourier series like is a sequence of limit of a sequence, right? Series is a limit of a sequence. So if you take first one term, maybe it will be the first line I draw. When you take many terms, it will be oscillating, and it's like this, and then like this. So that's how this Fourier series is like, one can approximate discontinuous function using discontinuous or any function using this cos x sin x function, right? If you see the visualization, I mean, if you see the if you do by yourself, then also it will be, you will see it very interesting. Okay, okay, these two lines are there, then the many terms, after many terms you will see, I mean, if you take maybe 2000 terms of a series, then the function maybe look like, the function mean, that's why I write f is approximately like this, the summation, and this summation n equal to 1 to infinity, instead of n equal to 1 to infinity, even if you take n equal to 1 to 2000, maybe this function, the that function is like this, oscillating and then like this. So it is quite approximating, right? So if you take n test numbers much bigger number, then that will converge to like this two line. Okay. Sorry. But what will be a not here? Just I want to say something about this interesting thing, because
minus
this is
1,
a
sir.
minus one, a not.
Wait a minute, sir. Just checking, sir.
No problem.
Sir, A not 1, sir.
A
Hello?
naught is 1. Yes,
Yes,
A naught
sir.
is 1. A naught will be 1 over pi, right? Minus pi to pi,
Minus pi to pi. Minus
but
pi
it
to 0, sir.
0 dx, right? So on, yeah, that you are correct. A naught should be 1. So what will be n? In this case, it is easy, right? At least in this case, one can easily. N will be 1 over pi. Same minus pi to 0, because function it's multiplied with the fx, and fx is 1 in this interval, so it is cos nx, right? Correct. That will be 1 over pi sin nx over n pi sin nx minus pi to 0, but whatever value you put, 0 is 0, minus pi also 0, so it will be 0, n is 0. So A also correct, B also correct. Now see on Bn, if you try to find, if you find out, then it will be okay. So Bn will be 1 over pi, again minus pi to 0 sin nx, right? But what is the value for sin nx? It will negative of n1 will come, so cos nx 0 to, sorry, minus pi to 0. So at 0 it will be 1, at minus pi it will be minus 1 whole to the power n. So 1 minus minus 1 whole to the power n over n pi.
Or one can write cos n pi also over n pi, that thing also be there. So 1 minus cos n pi. So ABC will be correct, right? Sorry, cos n pi minus 1 over n pi. Yeah, total negative also is there. So it will be negative of this. Yes, yes. So from here, what you can write this minus of 1 by n pi cos 0 means 1 minus cos n pi. So total the answer then it will be cos n pi minus over n pi. So D is correct, not B. A B D. This
D
is
is a
not correct.
BN.
Yes. Yeah. Another interesting question, I guess. Are you trying or I should write?
Yes, sir, trying, sir, trying.
Okay.
हेलो हेलो
Yes, yes, tell, please.
सर ए नॉट ए एन और बी एन निकाल लिया सर, अब इसके बाद क्या करें सर?
A naught, A and B n, you evaluated for this, right? Fx, if you write fx like this, then A naught, A and B n you have,
यस सर, यस
right?
यस सर.
Okay, yeah, but then this the thing, right? How what to do with like how to write the Fourier series for fx, right? So, but what is fx times fx integration of x times fx minus pi to pi? Can you say something about this? So that will be integration of minus pi to pi. This term you are multiplying twice, right? So if you multiply it twice, can you tell me whether it will be only remaining with plus n equal to 0 to, sorry, when you take n equal to 1 to infinity, it will be, yeah, n equal to 1 to infinity a n square cos nx times cos nx, right? That will be cos square nx and a n square plus b n square, n square times pi will want come into the picture and plus bn square pi. Do you understand this? So when you multiply fx times fx, mainly this term is getting multiplied twice. So when a naught by 2 times this cos n pi x or a n times cos n pi x you have, and then if you take integration that will be 0, you know, because cos function is periodic. I mean, cos nx, if you take integration over minus pi to pi cos nx, that will be 0. Now if you take a n over 2 times sin nx, that will be also 0 because sin n pi also 0 and sin minus n pi also 0. Only when a naught by 2 is multiplying with a naught, that will remain. Similarly, for these two also they are orthogonal. That's why only when you multiply cos n pi x by cos n pi x, so n times cos n pi nx and cos n times cos nx, that twice if you multiply, this will be this. And integration over minus pi to, sorry, minus pi to pi cos square nx, you will get that as pi, right? So that's why a n square pi and b n square pi remains. Do you understand that?
यस सर.
You got up to this, you got it?
यस सर, यस
If you
सर.
don't, if you did not, then tell me, no problem. So then 1 over pi, the question is given 1 over pi minus pi to pi fx square f square x dx, right? So that will be equal to 1 over pi minus pi to pi. This quantity, first quantity will be, first term will be a naught square over 4 times 2 pi. 1 by pi you are multiplying, so that's why it will be n equal to 1 to infinity a n square plus b n square. So what does this give? This gives a naught square over 2 plus n equal to 1 to infinity a n square plus b n square. So now you put, you know what are the values for a naught? What is what a naught you got? And a
सर
n
2 pi square.
2 pi square.
यस सर.
Okay. And a n
ए एन -1 ब्रैकेट में -1 to the power n by 2 pi.
how, or what is your fx? Fx equal to negative of x, right? A naught should not be 2 pi square. A naught should be 0. Okay. What you did, tell me. You can learn it better. So A naught is 1 over pi, right? Minus pi to pi minus x dx, right? That's all. Am I correct?
यस सर, यस सर.
Then what will happen? It will be 0, right? It's odd function and it is between minus pi to pi. So minus a to a, any odd function, that will be 0. And what about an? An also you will see it will be 1 over pi minus pi to pi minus x cos nx, that will be 0. Similarly, bn it will be minus x
Hello,
sin nx.
hello,
Yes,
hello.
yes,
Sir, we
yes.
can't take 0 to 2 pi directly, 1 by 2 pi, multiplying 1 by 2 pi.
No, it is here minus pi to pi. Already it is given. The length of the interval is minus pi to pi, right?
So we can't manipulate it from 0 to 2 pi.
Most probably not. If the minus pi to pi, your function is not this odd function and all these things are not there, right? So always you cannot do maybe. Can
So
check it.
when we can do that, because I did that and the answer got wrong.
Yeah. You did what? You did the like 0 to 2 pi.
Yes, I mapped this mapping minus pi to pi. I changed to 0 to 2 pi.
So when you do that, the function will change to x plus pi, right? X to x plus pi. That also you have to make change, right? You just change the
Okay,
domain, it's not the thing. You have to change the its value also. So that's why don't do all those things minus pi to pi. Instead of 0 to 2 pi, everything will be minus pi to pi. All other things will be same. No need to worry. Because the length of
okay,
the
sir.
interval is 2 pi. So you don't worry about that. So but you put minus pi to pi. Instead of 0 to 2 pi, you put minus pi to pi. All other coefficients, I mean like 1 by pi, all those things will be same. Okay. So Bn will be 2 times minus 1 whole to the power n over n most probably. So then what you will get, this will be 0 and n is also 0. Bn will be then 4 by n square. Summation n equal to 1 to infinity 4 by n square. So you see the last option, which is 4 by n square, that is correct. Got it?
Yes, sir. Yes, sir. That mapping thing is 0 to 2 pi and minus pi to 5. That was
don't do
waiting.
don't do all, yeah, don't do all those things. You just put it minus pi to pi instead of 0 to 2 pi. All other things will just keep same. Just blindly put wherever 0 to 2 pi, put minus pi to pi, and other things will remain same. So no need to worry about those. Okay.
Sir, when it is in a question 0 to 2 pi, then also we use minus pi to pi.
Then also you use, no, you don't need to use 0 to 2 pi, you use. What's the problem?
If it is given here 0 to 2 pi,
Yeah, 0 to 2 pi.
then we use 0 to 2 pi.
Yes,
Okay,
whatever
okay.
it will given. Yeah,
Whatever
whatever
is
given.
given, we have to use that.
Exactly, exactly, exactly. Yes. But things are same, right? No need to worry, right? Just integration limit will be changed. Nothing else. Okay, so this is okay, right? So we'll move to the next question then. Hello. So we'll do the complex
Yes,
Fourier
sir.
series one.
Yes, sir. Cn and C naught.
Yes. What you got?
सर फाइंडिंग सर अभी
Okay.
अभी
Okay.
कर रहा सर.
Okay. Okay. Okay.
Yes, sir. Solve, sir.
Yeah.
What is the answer?
सर हुआ नहीं सर, कैलकुलेशन में थोड़ा सी प्रॉब्लम आ गई यहाँ पे.
So you have used this Cn equal to 1 over 2L. In this case, it is pi minus pi to pi fx. So e to the power minus I nx, right, dx. Did you use this? You have to use this, right?
Yes, sir.
So once you use this, what is the value of fx? Fx is minus 1 or 1 depending on minus pi to 0 or not, right? 1 by 2 pi minus pi to 0 negative of 1, so it will be minus of I nx dx plus 1 by 2 pi, it will be 0 to pi, 0 to pi, it is positive 1, so it will be minus I nx dx. So what does this gives? This gives you 1 over 2 pi. The first one, what it will give you? E to the power minus I nx over minus in, but another minus is there, so it will be in, right? 0 to, so not 0 to, minus pi to 0 plus 1 over 2 pi, it will be minus inx over minus in 0 to pi, right? So if you do put it, the 1 by 2 pi, e to the power 0 is 1, so 1 over in also you can take common
सर
for
सर
both.
पीछे पीछे माइनस हटा दिया सर, दैट स्टेप.
Which minus 1? This minus 1?
यस सर, यस सर.
No, but minus in was there, right? I did cancel.
ओके ओके ओके.
Minus in also will come, so that get cancelled. 1 minus e to the power in pi plus e to the power minus in pi over minus 1, okay, minus 0. Yes. plus 1. Hopefully I am correct. Yes. Correct, right? So whatever I did correct. So then 1 over 2 in pi, I just write, times 2 minus e to the power in pi minus e to the power minus in pi. What are these? So 1 over 2 in pi 2 minus, this is cos n pi plus I sin n pi, right? Cos n pi is, let us keep cos n pi minus, sorry, plus I sin n pi, that is 0, minus again cos n pi minus I times 0, that will be 1 over 2 in pi 2 minus 2 times cos n pi, that will be 1 minus cos n pi over I n pi. What you got? The value for Cn. Just put it and you get whatever you want. Cn will be, see, then B option will be correct. Also, if you see it closely, B also, C also, three options are also same. They are same. Instead of cos n pi sin n pi, they are writing in I n pi form. So both the uh, options are correct. So this is explicitly 1 minus cos n pi by I n pi, that is this one. But again, this one also is same, because if you see it from this line gives you 1 over I n pi minus 2 I n pi. So this one is this also. So B also, C also, they are correct. This is not correct, this is not correct. Okay.
Yes, sir. Yes, sir.
Okay. Then what about this one? So instead of fx, this fx equal to x. X is given. Fx Fourier series is given.
Hello?
Yes, sir. Trying, sir.
Okay, okay.
सर इसमें इंटीग्रेट करके एक्स की वैल्यू वो एन की वैल्यू डालनी है ना 1 2 3 4।
No, I don't understand what you're telling.
Sir, first we have to integrate it and then put value of n equal to 1 2 3 4.
But do you get this 1 over n square that summation?
Yes, sir. Yes, sir. That form, we have to bring it in that form, sir.
Yeah. So here it is given f is n equal to minus infinity to infinity minus 1 to the power n I n e to the power I n x. I mean, which is nothing but n equal to minus infinity to infinity c n e to the power I n x. So now
if you try to find f square from minus pi to pi 1 by pi, that will be equal to cn square. Sorry, some is over. Equal to 150. Yeah, because n equal to, if you take n equal to 1 to infinity, then it will be 2 pi also will come, because twice the minus infinity also, and that will be twice, so that's why. You understand? It was like the before what we did. So when you multiply f with f mainly f, when you multiply with f, it will be summation n equal to 1 to infinity cn e to the power inx times the same thing, but this e to the power inx is nothing but cos nx sin nx. So when you multiply with sine, that will be 0, and when you only remaining with cos square plus sine square, that will be giving you 1. Cos square nx and sine square nx will be, that value will be 1, but the integration over that will be, if you take integration minus pi to pi, that will be, that 2 pi will come into the picture. So that's why this integration, when you take integration over minus pi to pi f square dx, that will be 2 pi times that cn square sum over n. So that's why you will get this. So now minus pi to pi, f square means here x square 1 over 2 pi also is there, dx is equal to, what is your cn? Cn is minus 1 whole to the power n in. So modulus of cn square will be summation of 1 by n square, n equal to 1 to infinity. Summation n equal to 1 to infinity 1 by n square, then it will be equal to 1 over 2 pi x cube over 3, and that will be then pi cube over 3 plus pi cube over 3. So 2 pi cube over 3, 2 pi square over, sorry, it should be pi square over 4, right? No, pi square over 3. Sum of the series will be pi square over 3, right? I mean, I am getting this, I don't know. Do you understand anyway?
Yes, sir. Yes, sir. Understood, sir.
You understand?
Yes, sir. Yes, sir. I will try, sir.
You can, if you like, you have some time, okay, so you can think about it. If you are not understanding, you can tell me also now. Otherwise, you can tell later.
B option, sir. B.
B option is correct, right? That's it. That's what we got. The crucial point will be this. Once you know this, then you're done. And so once you evaluate this, then you're done. We did similar thing before. So if you remember, yeah, this here also. A n square plus b n square. So when you take f square, that will be mainly coming as a n square plus b n square, the coefficient square. Here it is a complex representation of the Fourier series. So there you will see 2 pi will come, and that 2 pi will come instead of 1 over pi. So that's the difference. Otherwise, it's same.
This is okay?
Yes, sir. Yes, sir.
Okay. Uh, Wait, before starting this, initially I told that I will do maybe some questions from assignment 9, next assignment week 9.
It's a Fourier
But it
transform.
seems, yeah, again it is same Fourier transform, but I don't think we have time. Okay. Also, the this week it is assignment 9, right? Week 9 is going on.
Yes, sir. This week it is एक सेकंड सर चेक करता हूँ सर जस्ट मिनट सर
So, yes.
I will check sir.
No problem. I am waiting. No problem.
Yes sir, Fourier transform sir.
Not for which week assignment? Assignment
Assignment
number.
9 sir, assignment 9.
Yeah. So, but the last assignment you did, you were doing assignment and submitting or not?
Yes sir, last assignment complete sir. Solution also here sir.
But these are the thing I did already. I did whatever I did. Those were for assignment 8, right?
Yes sir, same sir, same sir.
Yeah. All the questions are same.
Yes sir,
Okay. Okay.
assignment 8 also gone, assignment 7 also gone. Assignment 9 is